Hello, everyone, and thank you all so much for joining today's take session. This is our last take session of 2025. We will be picking them up again next year with more topics. So today's session is being led by our head of product, Eric. Thank you so much for leading today's demo. Today, we are looking at how to master dynamic model workflows. 2 weeks ago, we looked at how you can build a static recommender that actually works. And today, Eric is going to take us through the process. So with that said, I'm going to hand over to him. He's going to give us a kind of practical walkthrough and a closer look at everything. So thank you.
Thanks, Madison. Yeah, I won't be able to see hands raised or chats or anything. So Madison, Jess, if you could just shout out if someone has any questions. So I don't know how many people in the meetup I did a few weeks ago about the dynamic model types. But just for some context, today I'll be showing kind of simulations and convergence of an ecosystem rewards dynamic recommender, which uses a Thompson sampling methodology. For those who haven't heard of that, it builds a beta distribution for each offer you want to recommend in each segment. To score your offers, it will sample from the beta distributions, rank the offers by those sampled numbers. The idea is that as an option succeeds, you increment a parameter of your distribution that shifts it to the right. And if it fails, you increment a parameter that moves it to the left. So as you gather evidence, the numbers that you sample from your distributions on average will be higher from the distributions that are doing better. Because the distributions peak as you gather more information, that allows you to balance your explore and exploit. Very quickly, high level, that's kind of how the ecosystem rewards Thompson sampling thing works. I'm going to be talking more through like practically setting one up for the platform and how you would set the parameters and look at the simulation and all of those things. Let me share my screen and start doing that.
Before you jump into that, Eric,
sure.
We do just have a question in the chat, and it's more a bit of a context about ecosystem AI, and asks, Eric, please could you just give a bit of background about the company? So yeah,
sure.
Just a quick bit about us.
So yeah, we're basically a company that combines kind of behavioral insights and real-time machine learning deployment to help companies improve how they interact with customers. So it's kind of human-centric, human-focused AI engagement platform. The key things are real-time model serving and incorporating behavioral components into the product. And also, I'm sure Jess can share the website link in the chat as well.
Absolutely. I'll drop a couple links in there for you to navigate.
Okay. So, like you would have seen in previous ones, we have a graphical interface that you can do all of this stuff in, but I thought it would be worth showing the Python version. First, there's importing various packages. Here we authenticate to our ecosystem instance. This will be the server where we're going to be setting up our configuration that we're going to be pushing to the runtime, which is what we use in the production type environment. We've got a few parameters.
Are you sharing the word?
Sorry, I may have done my share incorrectly.
Yeah, we can see the books now,
okay.
Yeah.
Okay, cool. So as I was saying, there is a graphical interface. Everything I'm showing here, you can also do in that interface, but I'm just going to talk through the Python version of things. So yeah, there's importing your packages, and then here we authenticate to the ecosystem server to allow us to set up our configuration that we're going to push to the runtime that does the serving in the production environment. So it's just a couple of parameters we set, what we want our deployment to be called, and the version of that deployment, and then where our runtime endpoint is located. So in this case, I'm just doing a base runtime at port 8091, and we're going to kind of any tables or anything we need to create in the interaction science database. And then we also connect to our runtime endpoint that we've specified. With that preamble, we get into the actual setup. So,
Eric, sorry, just before we get to that, I had another note. I just want to confirm, so is this a question or a comment?
But is that not
I think it's a question.
That is fascinating. Would be good if you can speak how RL plays a role about the real time.
I think it might be reinforcement learning.
Oh, reinforcement learning.
Yeah.
Plays a role. Yeah.
Cool. So it's definitely a good question. I think something that we focus on is having that explore, exploit trade-off being at the right level. And also you want to strike a balance between what is an outlying sort of behavior that's not informing future interactions and what is a shift in behavior that you want to learn from. Because I think a big focus of what we've seen and something that we focus on is human behavior is quite inherently dynamic. So if you don't have a system that can understand a real-time context, so that's the first thing. If you want to engage with people based on the moment that they're in, you have to be able to, one, have that data, and two, be able to use it. So if you can do both of those things and then use that to, in real time, produce a prediction that will inform an interaction with that person, then you can engage with them in the moment that they're in, and then you can learn from that interaction and improve your prediction. As long as you have your explore ratio or approach set up right and you are experimenting effectively, you can pick up those shifts in behavior and change the way that you interact with people as either circumstances change, your competitors do something else, or there's a big external event, or that person's life changes. All of that can have an impact. If you're in an environment where people are interacting very regularly, like banking, you can actually run that learning on an individual level. You can learn from someone's interactions with you at an individual level rather than doing it in a segmented way by using a bunch of features. That can also be quite useful because that's how that person behaves. And as long as you have the context right, you'll never have perfect context. Some things will look unexpected in ways, but in the ideal world, if you had all the context, you would be able to understand what's going on a lot. Another thing we're kind of starting to look at that I think is also quite interesting in this space is focusing on causality, not just predicting what is going to happen, but understanding why things are happening and the impact that they're happening. So kind of combining like experimentation with LLM, like semi-reliable experts, kind of causality quantification mathematics that's been developed over the last couple of decades can give you quite a powerful insight into understanding and predicting future behavior as well. So sorry, yeah, no, that was quite a long answer to a short question, but hopefully it was interesting. Were there any other questions that I missed? Okay, cool. Okay, cool. In this example, we're setting up a basic set of 3 different messages to tell someone we want to give them a 10% discount. We found that the way you talk to people can have a big impact, and experimenting and learning from different types of content is effective. So we're setting up this, get 10% off your next purchase. We're excited to offer you a 10% discount, or thanks for everything, get 10% off your next purchase. We're going to set up our contextual variables. So we're going to learn by personality types. Are they enthusiastic, industrious, intentional, experiential? These are those interaction personalities we've spoken about in other sessions, and level of education. Based on which bucket of these 2 variables these people fall in, we will track a distribution of the effectiveness of these messages for each of those buckets, and then use those distributions to decide which message we present to each person. We set up those configurations and then create our setup feature store. And then we use that setup feature store to create our dynamic recommender or online learning configuration, sampling sort of parameters. We use our authentication to the server. We name it using our deployment ID that we set up, give it a description. Then we set up our setup feature store. This is a data set that contains information about what we're trying to recommend. It's a fairly bare bones list of what we're recommending and the segments we want. If you have historical information you want to use as a warm start for the algorithm, you can include that as well. We're storing the setup feature store collection with our database interaction science that we defined earlier. And then our options store is going to be this messaging options in the same database. The options store is the the collection that's kind of stores the state of learning of the system as it is learning from the logged interactions. This option store will update and kind of keep the history and the current state so that when the storing happens, that is easily available. Then we have our success and fail rewards. This is the amount that we're going to be shifting our distribution as interactions succeed or fail. So the standard Thompson sampling approach is just to do like this. The parameters we're updating are alpha and beta in a beta distribution, and the standard approach is just to do one for each of them. We found that we're interacting with the customer, there's more information contained in a success than a failure. So we have the ability to adjust those parameters. For this case, we've set them to be 0.5 and 0.05 instead of 1.1. It also impacts how fast things converge. The higher you set these, the more impact on the convergence of your distributions each interaction has. If you want a success to be incredibly impactful and you set that to 10, then once something succeeds, it will become incredibly likely to be offered again. The same thing for failures if you want to do that. Then we have our history windows. You can set both a time window and a count window. Generally, if you're using this sort of model, you're doing it in a dynamic environment. So you don't want to use too much history because at a certain point, history stops being useful because it's outdated. So we set up 400 interactions a week back. Then we set up our fields on the setup feature stores. We've got our offer key, which is message, then our two contextual variables, personality type and education. We're saying that we want to look them up from a data source. So you can pass the values in through the API call. But in this case, we're going to be looking it up from feature stores. So we're looking them up, and the name of the field in the data store that we're looking up is also going to be personality type. So in this case, they're the same, but it could be that for some reason your feature store field has a different name, but you can set that up here. And we're going to kind of update our existing setup. So if we run all these, we'll create our online learning configuration. If you're in the workbench, that's the setup here. So we've got our interaction sites. So we've got now our configuration. So now we need to set up our deployment. To do that, we set up two things. The first is linking our multi-on bandits configuration that we've created. We get the UUID for that configuration and add that to a deployment object. We set our epsilon to 0 because we don't want to do any additional kind of epsilon-based exploration with this configuration. Then we set up our customer feature store. We're going to look up from the customer feature store data set. It's a Mongo lookup. And we're going to use customer as our lookup key. And then we just add those two pieces of configuration to a deployment step. So we create deployment with our authorization, our project ID and deployment that we have from our setup, description, which can be whichever it needs to be, our version that we set in our pre and post score. So these are custom a place where you can have custom Java code to manipulate things as before and after the scoring happens. In this case, we're just going to use the templated versions. So we've got our pre-score dynamic and the platform dynamic engagement. So if you need to do something very custom, you can have a custom Java class, but it's not necessary for this. Then we set our endpoint, our Mongo connection details, and link out to configurations we created for our parameter access and our multi-on bandits configuration. So then we've got our deployment step, which again, if we go into the workbench, we can see if we go into the interaction science project, there's this one meetup deployment step, which will have those settings that we've created. We can then push this to our runtime endpoint. So this will do the deployment. You print out an error if something goes wrong, or just the properties file that is then sent to that runtime. Here's a place where you can do a quick test call to see that it is producing a result. So you can see that we asking for one offer and we're getting back, thanks for everything, get 10% off your next purchase. is the offer that's being presented for us, with a whole lot of extra information returned in case it's needed around the segment that this customer was in, the values of alpha and beta, and all of those sorts of things. So then we've got a kind of a working deployment. The next thing we want to do is test using a simulation that the deployment is working as expected in terms of the learning. So that's where a simulation is very useful. So in order to run a simulation, there's a few parameters that we set. The first is how many iterations do we want to run in our simulation. So are we going to do 100 iterations? And what we want our take up to be for our product that we're simulating. So obviously this is something that you can, if you want to define in a very complicated way. At the moment, we just want to check that the learning is happening. So I've just set a random take up rate for those 3 offers. You may want to use a separate model to simulate how likely an offer is to be taken up for a specific person, based on historical data. It depends on what you are wanting to prove and validate using your simulation. So you can make this simulation of take up as accurate as you need it to be. For now, we basically just say, for this message, there's a 10% chance that someone will take it up when offered it. For this message, there's a 16% chance. And for this message, there's an 88% chance. Then we kind of define our API parameters for invocations call to the runtime. So we're going to do this deployment. We want our channel to be notebooks. We don't have a sub campaign. The user ID will be, we test the customer will be replaced in the simulation. We just want one offer, and there's no specific kind of generic parameters we're passing through. And then we run our simulation. This again will also be probably varied depending on exactly what you're trying to simulate. But this is an example of what we're doing here. We are getting a random customer. We're going to our customer feature store that was configured. We're just checking that there's some indexes created on it to make the lookup faster. We're getting a sample of one person ran from that database and getting the customer number from that lookup. We then have the customer we want to use and put that into our API parameters as the customer field. Then we call our invocations API with those parameters. We do a check that the response actually contains a result. If something goes wrong, you'll get an empty result printed out. In this case, we'd rather pause and understand that rather than continue the simulation, depending on what you want to do. Maybe it's sometimes right for people to not receive offers if they're not eligible for things. But in this case, if something goes wrong, we'll print out the logs for that runtime that the empty response was returned so that we can see what went wrong, because in our case, it indicates that something has gone wrong. And then assuming that we do have offers, so something didn't go wrong, we'll extract from our JSON structure the offer that was recommended, and we will then simulate taking up that offer or not. So again, that's something that you can do in as complicated a way as you want. Here we just check, is the take up bigger than a random number? Like I said, following these thresholds. And if it is, we call our response API, which is used to register success of that recommendation and log it so that it can be used for future learning, in order to just make examining the results more accessible. We just call the learning API, which just forces the learning to happen so that we don't end up in a situation where we've got some data and the automatic learning hasn't triggered yet. So you don't see the results of your simulation. So we just call this learning API to make sure that when we look at our results, it incorporates the learning from the latest data. Once we've done that, we can look at the results of our simulation. To do that, we use this ecosystem reward box plots function. What that does is it lets us plot the distributions of the offers for each of our segments. Basically, what this algorithm does is for each segment, it will build and track a distribution of the effectiveness of the things that you're recommending, and then score by sampling from those distributions. So in this case, you can see in terms of how to read these, this is the bounds of the distribution. 50% of the distribution lies in here, and this is the mean of the distribution. You can see that these two are pretty uniform still, which means there's not a lot of knowledge about them. And this one has become quite shifted with a peak near 1. And that makes a lot of sense because there's quite a big discrepancy in our take-up rates. These two are pretty low, and this one is very high. You can see that for this offer, we've started shifting a lot of our distribution to the right, which means that when we score, it's much more likely to have the highest score. However, there's still a chance that either of these can have a number that is higher. That is where the explore-exploit trade-off happens. We don't have a lot of information about these yet because they're not doing that well. They still are kind of enabled for exploration. What I did here, you'll see, is this doesn't actually depend on the segment you're in. And what that lets us do, because the segments aren't equally distributed in the data, you can see kind of how this changes as like number of interactions increase. So here there's slightly less data, so you can see this distribution is not quite as peaked yet, but this is an even more extreme one. There's now a lot of data in this enthusiastic grade 12 segment. You can see that the algorithm has strongly learned this is, at the moment, our most effective message. It's still not impossible. One of these messages could be presented because we still want to explore. By far, the most likely outcome is that this message is presented, which is what we would want because that is a very extreme discrepancy. You can see it is starting to learn that this get 10% off is the slightly more effective. These two are close enough together relative to this one that it's not really learning to differentiate between them. You can see when there's not a lot of data, distributions are still more overlapping, but it's starting to shift. Here there's very little data with enthusiastic and PhD. So you can see, even though this is different segments, as the simulation runs, you could see the distribution going from that to that to that to being at the end very converged around this specific offer. The idea is that if these take-ups are shifting dynamically, then because it is still exploring, it will pick up that shift and start moving those around. And even if it doesn't explicitly offer these, as this starts underperforming, the distribution will start shifting back down. And if this is performing, when it does start becoming explored again, it will shift it up. So that is how the learning and dynamic nature over time happens. We've got a distribution here for each of these segments. If you have different take-up rates that you expect in different segments, which you should do if you are adding the segmentation, you can look at each of these distributions and see, given the number of interactions that happened, is the learning happening in a way that you would expect? Are you happy with the rate of explore and exploit that's going on? And are things performing in the ways you would want them to? Once you're happy with that, so this would have been a deployment to your QA or dev environment. You can then change your project status to deployment and put in to production, and put in the endpoints that you will have in this configuration here. You can configure a separate endpoint for your production environment. And if you change this project status to production, it will then push to that endpoint instead of to dev QA endpoints. You'll then have your predictor running in your production environment and this API being consumed by your front end. You could then shift over to using your Superset and Grafana dashboards to monitor things and check that, do these beta distributions look like you expected, and how are the predictions performing? So yeah, that's the journey that I prepared for today. There's a bit of time left. I don't know if there's any other questions, or we should end the session.
I did have to refresh, so I don't know if I lost anything in the chat.
There's nothing in my...
No, I don't know if anybody has any questions or comments or anything you want to check with Eric before we close off our session.
Cool. Thank you so much, Eric. We have one comment.
Yeah, the simulation part of it would definitely be related to digital human twin. I think it depends like what you want your simulation to do. Like the more accurate it is, the more comfort you can get around how things are going to perform when you actually go live. Like the ultimate thing is to actually, potentially go live with it for a portion of your traffic and see how it runs. The more closely you can twin your simulation, the more an understanding you can get of what it's going to behave like when you actually expose it to real people. But exposing it to real people is always the ultimate test, because you can never change the environment by interacting with it. So it's very difficult to completely accurately simulate how that's going to happen. So yeah, there's almost always going to be something that you didn't anticipate, which is why it's useful to have that dynamic learning happening so that it can ideally adjust for that in an automated way.
Thank you, everyone.
Thanks, everyone.